welcome to today's webinar, S3 Best Practices, a Decade of Field Experience. Our presenter today is Omer Gilani, Senior Product Manager. Today with us we also have Drew Myers, Senior Product Marketing Manager, Carl Summers, Software Engineer, Vo Vuong, Senior Manager Developer, and Susan Chan, Product Manager, as our webinar moderators, who will be engaging with you and answering your questions throughout the presentation. Omer, welcome. The floor is now yours.
Thank you. And everyone, welcome to the webinar for Amazon S3. So we have a lot of great content today. A quick look at what we're going to be talking about. I'm going to spend quite a bit of time talking about some of the new capabilities we've added to the S3 platform, specifically helping our customers manage their data on S3 and get more value and derive more value from their data on S3. We'll talk about a new storage class that we announced last year, specifically designed for infrequently accessed data. We will also, along the way, talk through some of the best practices that can help you improve performance of your data on S3 and also leverage some of the great security capabilities we have to make your data more secure on S3. We'll also talk about a new service we announced just recently, which is S3 Transfer Acceleration, which can help you move data faster over the internet to S3. So with that, let's get started. But I did want to call out, we have a lot of great folks helping us out with the webinar today, and I would encourage you to enter your questions and engage with us, and we'll make sure that we get to those questions at the end of the webinar and talk about it. So with that, let's get started. So before we dive into S3, so Amazon S3 is actually one of the first storage services that we launched for AWS. But very early on, we heard from customers that not all data is equal. Data comes in many different forms and many different formats, and as such, if you have files that you want to store in the cloud, you need a different set of capabilities as opposed to saving video or objects. And so while we saw great growth, and we continue to see great growth in Amazon S3 and Glacier, we wanted to make sure that we think about the storage offering from AWS in a breadth-first manner. And so as such, we're going to continue to add more capabilities to our platform. And really, we think about, at AWS, we think about storage as freedom of choice, right? This is about providing our customers with the right set of capabilities so that the data is able to kind of leverage that, leverage the right set of capabilities for that format of data. So if you have data that is in file format, we have Amazon EFS that can help you have a dynamically scaling file server offering. We also have elastic block storage that you can use with your EC2 instances for persistent storage. And then, of course, we have Amazon S3 and Glacier, which is ideal for object storage in the cloud, scaling dynamically with high durability and high availability. But storage offerings themselves are not enough, right? A lot of our customers, specifically the customers who are kind of on their journey to transitioning and transforming their data and moving it to the cloud, ingestion of that data and ability to transfer that data from on-premises or from their end users to the cloud is very important. And we focus a lot on that. We offer our customers the ability to use Direct Connect to establish that high bandwidth pipeline between your on-premises data center and the cloud. We last year announced Amazon Snowball, which is a device that you can have shipped directly to your on-premises data center, connect that to your network, and then ship that back to AWS and use that as a way to ingest data into S3. We work very closely with our ISV partners to make sure that all the storage appliances that you know and love work seamlessly with Amazon S3, as well as our other storage services. We announced Amazon Kinesis Firehose, a way for you to ingest streams directly into S3, so you can start building your data lake around S3 and then leverage all the great services and the great ecosystem that we have to offer on top of AWS. We'll talk more about the new service that we just announced, which is S3 Transfer Acceleration, which allows you to move data across long distances in an accelerated manner and ingest that directly into S3. And then, of course, we have Storage Gateway, which again allows you to establish that connectivity from your on-premises data center to the cloud. So kind of in all, you see a lot of choice, and the focus really is to kind of make sure you have the right set of capabilities for your specific use case to have an overall and comprehensive storage offering from AWS. So with that, let's shift our focus to S3. And before I talk about some of the new capabilities that we've been adding, I wanted to touch base on our core customer promise. At the heart of it, S3 is a dynamically scaling service that provides our customers with extremely high durability. Our promise is 11 nines of durability, and high availability, our promise of, and we're designed for 4 nines of availability to make sure that when you need your data, it is always available, it is always there for you, so you never have to worry about ever losing your data when you put it in S3. It is available for you, so as soon as you need your data, you are able to get it using a very simple REST interface. And of course, and this is a big one too for us, that the service is extremely scalable. We have customers who who have all the way from gigabytes to hundreds of petabytes, all the way through exabytes on us. And a big part of the value that we deliver is completely dynamic scale. You never have to worry about hitting limits, or never have to worry about provisioning more storage, and that's a big part of the value too, is that any of the capabilities we add to the platform, we make sure that it can handle S3 scale. It can handle scale all the way from gigabytes to exabytes, and our customers never have to worry about that. So let's talk about some of the new capabilities we've been adding to the platform. This is not a comprehensive list. In fact, there's a lot of capabilities we've been adding, and we've been very busy with this. And so I would urge you to go look at some of the documentation that we have available. There's a lot of great talks available, and for each one of these services that we've launched, we have focused documentation that you can go look at. It should help you get started with this as well. I'm not going to go in detail for a lot of these, but to kind of just quickly give you a summary view of some of these. We launched event notifications, which is the ability for you to trigger notifications to multiple destinations when a specific action happens with your data in your S3 bucket. For example, if you put a new object in S3, you have the ability to configure S3 to trigger a notification to multiple destinations, including SNS, SQS, and Lambda. So for instance, you can write a specific Lambda function to take action when a new object shows up in S3. So if I want to update a secondary index, if I want to transform data, if I want to transcode a video file and so forth, you can now use this event-based computing paradigm instead of polling and trying to find out whether you have new information in S3. Simply having S3 trigger the right end function, whether it's SQS, Lambda, or SNS, and then use that to perform and proceed in your workflow. A lot of our customers are doing very interesting things with event notifications, and we continue to make this platform better. We added the capability to trigger notifications on delete actions in addition to put, but also the ability to filter on specific prefixes. So you now have the ability to trigger a put notification on one of your prefixes, and then maybe a different notification on delete when an object gets deleted from a different prefix, which really gives you a lot more control in terms of when specific triggers happen, and so that your workflows become enriched and you can do a lot more interesting things with them. We also, so a lot of our customers kind of came to us and told us that for compliance reasons, a lot of times they have the requirement to have a copy of their data replicated hundreds of miles apart. And so for use cases like those, we announced the ability to set up cross-region replication, which is very easy to configure policy on your bucket that then essentially ensures that any new objects that are added to your bucket are then replicated to a different destination bucket in a different region. So specifically for those customers who, for compliance reasons, need a second copy of their data in a different region, they're able to easily set up a policy, and then S3 then ensures that all of that data that's coming into their bucket gets replicated to a different destination bucket in a different region. There are other advantages of this as well. One of the use cases we've heard from customers is additional security and protection against rogue users. A lot of times our customers, since they use S3 as a data lake, put a lot of very important and sensitive data into S3, and, such as logging information, and then allow access to that to a large part of their organizations, so their users can leverage other services in AWS and start analyzing and getting more value from the data. But at the same time, you want to make sure your data is protected, even against even for the people that you've granted access to. And so creating a secondary copy, replicating it in a different region, which is completely locked down, allows you to get that additional peace of mind and that additional layer of protection. We also announced VPC endpoints for Amazon S3, specifically for customers who are using the virtual private cloud capability, which allows you to have an isolated network on AWS with your own IP range and IP subnet. For those customers, they had to set up firewalls and NAT instances and actually manage those NAT instances if the application running in the VPC needed to talk to S3. And not only that, in order to get access to S3, even if it's in the same region, beyond going through the firewall or the NAT instances, the traffic actually had to go over the internet to talk to S3. So we heard that feedback and we added the capability that we're calling VPC endpoints for Amazon S3, which really ensures that when an application within a VPC needs to talk to the NS3 bucket in the same region, traffic never goes over the internet and customers do not have to worry about setting up internet gateways or NAT instances. So that makes it very easy to set up while still keeping a lot of control. So you have the ability to set a VPC policy on your VPC endpoint, which ensures and limits specifically which S3 buckets this VPC is allowed to talk to. But you can also go set a policy on your S3 bucket, which lists out all the VPC endpoints that you're granting permission to that can then talk to this S3 bucket. So you have a lot of control, and you can make sure that the right VPC is talking to the right S3 bucket. And of course, the traffic never goes over the internet is the added advantage there. As a lot of our customers grow on S3, in fact, S3 now has trillions of objects, which is extremely high scale. We hear from a lot of our customers that they would like to get more visibility into their data. Right? As a customer, I would like to understand what data I have on S3 because the volume is continuously growing, and actually be able to understand my usage of S3 as well. So to that end, we added the ability, we added actually 3 new CloudWatch metrics. So CloudWatch is our monitoring service on AWS. Now by default, all S3 buckets emit CloudWatch metrics for total number of objects within a bucket, as well as total number of bytes for standard or new storage class, Standard-Infrequent Access, as well as the reduced redundancy storage. So now you can track over time how your storage is changing, how the number of objects is trending, whether it's going up or down, and take meaningful action based on that. We also integrated with our audit trail service, which is AWS CloudTrail. So now you can enable a free service with CloudTrail where you will see all of your bucket level APIs such as creating a bucket, deleting a bucket, changing ACLs or policies or lifecycle policy on your bucket. All of those APIs are now audited and tracked as part of your overall CloudTrail log. So you have a way to go back and know who changed my bucket, when did that change happen, and what was the end result of that. Which really kind of gives you the additional auditability for compliance reasons that you can then use and know exactly when your bucket was changing and how that was actually changing over time. For some specific use cases, some of our customers told us that they would like to increase the default bucket limit on their AWS accounts. So by default, you can have up to 100 buckets. And there are specific use cases where you might have different end users and will want to isolate your specific users by bucket. In those cases, we work with you now and we allow you to kind of create more than 100 buckets. The process is actually very simple. You can simply open a support case if you think that you need more than 100 buckets, and we will work with you, understand your use case, and increase your bucket limit accordingly. Now S3 is a very large distributed system, and as such, for our update and delete operations, S3 is eventually consistent. And what that means is if I update an object or if I delete an object, that action, and I get a success back for that action, eventually S3 will get to a steady state where that object will actually be removed or appropriately updated. However, if I update an object and I issue a GET request immediately, I may get the previous version because, again, it's a distributed system. So you need to build your applications to be able to handle these situations. This is also true for putting a new object. However, based on customer feedback, we've changed our platform, and now all endpoints in all regions in S3 are read after write consistent, which means if you put a new object in S3, you can immediately read that object and be ensured that you will be able to see that object and see the right version of that object. Of course, it doesn't stop there. We also announced a new storage class for S3 specifically designed for infrequently accessed data, and we'll talk more about that as you proceed in the presentation. We also continue to innovate on our lifecycle platform, which is really the focus of the lifecycle platform is to help our customers focus on building their applications rather than managing their data on S3, and especially at S3 scale. There's a lot of repetitive tasks that you might have to do to be able to effectively manage your data. With Lifecycle Platform, though, we take those repetitive and those cumbersome tasks away from our customers, such as, I want to tier data in a year after it gets a year old from S3 to Glacier because I want to simply archive it. Or I want to delete log files after a year because my policy does not require me to keep those. It's those actions that you would have to perform then on hundreds of billions of objects potentially, right? All of your data in S3. You can simply set up a lifecycle policy, and S3 will then, in an efficient manner, perform those repetitive and those housekeeping actions so that you can focus on building great applications on top of S3. Now, we continue to innovate on the lifecycle platform, and there's 2 new policies that we've announced this year that can again help you manage to manage your data effectively on S3. One is what we're calling expired object delete marker. Specifically for version buckets, you have the ability to set a lifecycle policy to expire an existing object and move it from a current version to a non-current version. In that case, and then in addition to that, you can set an expiration policy to actually delete the non-current versions as well. However, there is a situation where you might end up with an object that has a delete marker, which is really an indicator that there is no current version of this object and all the previous versions have been deleted based on the policies that you have set. However, you can end up in a situation where you have delete markers with no current versions, no non-current versions under it. And you can simply list those and delete those yourself, or you can leverage this new policy to simply say if there is an object that does not have any non-current versions under it, and I end up deleting the current version as well, S3 will take care of cleaning up the delete marker for you. Similarly, we have the ability to upload multiple parts of a large object, which can really help you get better performance, and we'll actually talk about how you can leverage Multipart to improve your performance as well later on in the presentation. But when you do use Multiparts, there are situations where either your application might die or you might not end up completing the Multipart upload, and you have some parts of your object uploaded but not others. In that case, of course, you do incur storage cost for the incomplete multiparts that are uploaded. You can now set a simple lifecycle policy to go ahead and delete incomplete multipart parts that actually don't complete in X amount of days, which again is an easy way for housekeeping and managing large volumes of data, where the customer now does not have to go list all incomplete multiparts, make a determination, and then go ahead and delete some of those. And then, of course, I mentioned earlier a new service that we announced, which helps customers move data with high performance in a more efficient way across large distances. So let's talk in more detail around the new storage class, Standard-Infrequent Access. So we heard from a lot of our customers that data actually evolves over time. If I put a new object in S3, the characteristics of that object and the usage patterns that object sees does evolve over time, right, based on what I'm actually doing with my application. One canonical example we hear from a lot of our customers is if, for instance, I have a video file and I upload that to S3 and my application, and this is new content, more often than not, that content is going to be very heavily used. It might be a document that I upload that I use, that a lot of people are editing because it's a new document that we're working on. But over time, this document and the access frequency and how interactive I am with this object changes and reduces all the way through the end where it's ready to be archived. Of course, we have S3 standard designed for active data, where your data is available at the best possible performance, available immediately for you to use. And we also have Amazon Glacier, which is on the other end of the spectrum, which helps you store archive data at extremely low cost, but there is a retrieval time to get that data back. But what we heard from customers is data does not change from being active data to archive data overnight. Right? Usually it's a process where the access frequency of the data changes and reduces over time, all the way to the point when it's not being used at all and is ready to be archived. There is an opportunity for customers to save on storage cost if they weren't, if it doesn't make sense for them to put their data in S3 standard, because while they do need their data immediately when it's required, it is infrequently accessed, and that is really the goal for this new storage class that we've designed, specifically around infrequently accessed data. And so now you have this additional storage class, which is lower cost than S3 standard, that allows you to which is perfect for data that is that when you need that data, it is available at the best possible performance, but it is infrequently accessed. Therefore, I might put data in S3 standard and then move it to standard infrequent access when the access frequency goes down, and then when that data is ready to be archived, I can simply move that into Glacier. We talked about some of these use cases already, right? But some interesting use cases that we've heard from customers for this new storage class, infrequent access, is file sync and share, specifically around consumer file storage use cases, where a new document, when I'm working on it, when I'm editing it, or interacting with it, or collaborating on the document, it is very frequently accessed. I want to make sure that my application can get the best possible, and my users can get the best possible performance, and the data is obviously always available. But over time, my files do get less frequently accessed. I still want to make sure that my end users get and are able to load this file as soon as possible with the best possible performance. But it isn't accessed every day, or it is accessed at a much lower frequency. Same thing is true for backup and archive, specifically around disaster recovery, where I might be creating a backup of my data and may not get to that for very large amounts of time. But when I do need to do that recovery operation, I need to make sure that that data is available immediately, because this ties into my business continuity. And then also for long retained data, right? Data such as logging information, where I keep a lot of logging information, because when I do run into an issue, this is very useful for me to go debug or go troubleshoot, or even just analyze my usage patterns in my application to make it better. But it's these large volumes of data that I keep over very long periods of time. I don't necessarily analyze all the logs every day. And so that is another use case where it makes a lot of sense to use the standard infrequent access storage class and save on storage costs. So let's dive a bit deeper into the infrequent access storage class. We wanted to make sure that customers never have to worry about ever losing their data on S3, regardless of whether you're saving that data on the new standard infrequent access storage class, or Glacier. So with standard infrequent access, you get the same durability you get with S3 standard, which is 11 nines of durability. Standard infrequent access is designed for 3 nines of availability, which really means that 99.9% of the time when you do a get operation on your data, it's going to be available. For the 0.1% when it isn't, you can simply do another get request immediately after and actually be able to get the data, and it's going to be available for you to use. One key part, though, is we wanted to make sure that when customers access and request and interact with data that's in standard infrequent access, they get the best possible performance, right? Essentially the same performance you get for S3 standard. And that we think is a big value add and value proposition for infrequent access, because you want to make sure that your users do not pay in terms of lower performance when you're trying to save on storage costs. And with infrequent access, you essentially get the same throughput, the same performance as you do with standard. The other big part of this is, regardless of what storage class you choose, in S3, you essentially have the ability to put your data in the same bucket, right? So your application never really has to change when you're transitioning data from standard to standard infrequent access. And we leverage our lifecycle platform to be able to do this. It's the same REST interface. The identity of the object does not change, neither does the location, so you don't need to move your data from one bucket to another that's focused on infrequent access, which of course would be work for you, and you would have to change your application in order to be able to handle that. The identity of the object is exactly the same. The bucket is exactly the same. You simply just tier the data from standard to infrequent access without the application ever knowing. And so you need no changes to your application. You can use the same simple REST interface. The other thing I wanted to call out is you can, and in a lot of use cases, it actually does make sense for you to put data that happens to be infrequently accessed from day one directly into this new low-cost storage class. And you can do that using the same put object REST API simply by specifying the storage class. Security is always top of mind for S3 and AWS. And as such, all the different security capabilities that we've added to to S3 over the years, such as the ability to encrypt using server-side encryption, bringing your own keys, or using KMS managed encryption keys. You can use all of these just like you do with standard with this new storage class. And of course, all the other capabilities that make data management on S3 easy, such as lifecycle, the ability to version your objects and emit notifications, all work with infrequent access just like they do with standard. So with that, let's switch gears a little bit and talk about the other new announcement that we've recently done, a new service that allows you to optimize data transfer to S3 over the internet. Especially when you're moving data across the internet and across large distances, it's very hard for you to optimize performance over the internet. Specifically because a lot of times you don't have control, right? You don't know where your traffic is going to be routed, and your throughput is only as good as the weakest link. And so there are solutions out there that do help you optimize this throughput, and specifically those proprietary solutions, but they are very complicated to set up and manage. A lot of times they do require you to install software on your client side, or even at the server end, so that the end-to-end the optimization happens, but then you need to install the software, configure it, and maintain the software at both ends. And of course, these are expensive solutions, right? A lot of times there's upfront fees or fees for per gigabyte transfer all the way up to the order of dollars. And so kind of hearing this feedback from customers, we decided to work on and introduce this new offering, which is Amazon S3 Transfer Acceleration, which is really a service focused on optimizing your performance and throughput for those use cases where you're uploading data and larger files across large distances. And by large distances, we really mean uploading data across continents. Now, when you do upload data from your client to an S3 bucket in a different continent or over a large distance, you don't really know the exact route that your traffic is going to take. And like I said before, it's only as good as the weakest link. With transfer acceleration, however, we leverage the global infrastructure we have for AWS and allow you to make a short hop to the nearest AWS edge location, from where we used a lot of optimizations on routing as well as on the networking layer, and actually leveraging the infrastructure and the backbone that Amazon has to then send that data directly to your S3 bucket in a different region, in a different continent, at a significantly higher performance. In fact, in a lot of our internal testing and feedback that we've heard from beta customers, under certain conditions, you can see up to 400% improvement in performance over large distances. We also wanted to make sure that it's extremely easy to be able to use S3 Transfer Acceleration, so you don't need to make any changes to your code or your application. You simply need to point it to a different endpoint, and then AWS and S3 will make sure that we automatically identify the edge location closest to you and actually leverage that when we upload the data to your S3 bucket. Of course, and because of that, you don't need to worry about any firewall exceptions. You don't need to worry about making any changes or adding any software to your clients. So here's a quick look at the flow on how this works end to end. So if your client is, if you decide that you want to use S3 Transfer Acceleration on your client, you simply need to just change the endpoint, right? So instead of saying my bucket name.s3.amazonaws.com, you simply say bucket name.s3/accelerate.amazonaws.com, right? That's pretty much the only change you have to make, in addition to a checkbox on your bucket to say that this bucket I want to enable transfer acceleration. And the way this works is that, so in order to do that put API call, we resolve using Route 52 the IP address for and auto detect and resolve the IP address for the closest AWS edge location to you, and then leverage that edge location and the Amazon backbone to then send data over HTTPS all the way to the end region you want to put your data in, and then we have an EC2 proxy fleet running under the covers, which will then make sure that we put your data to your S3 bucket. Now, all of this is completely transparent to you as the user, right? The only thing you need to do is check a box on your on your S3 bucket to enable transfer acceleration and simply point to a different endpoint. The rest of it, we make sure that we auto-detect and get to the closest AWS edge location to get the best possible performance and other optimizations that we've done to make sure that we can leverage the AWS backbone in an optimal way, such as we leverage maximize the connections that are there and avoid reconnects so that the time to set up is saved and so forth. But really this has been designed for sending large objects to over long distances, right? And that is a key point. And you know, here's an example of some of the internal testing that we've done, where if you put data over the public internet, the further away you are from your endpoint. In this case, we were putting data into a bucket in Singapore. The further you are from your end destination, the higher delays you see, right? The higher impact you see on your performance. With S3 transfer acceleration, however, you're able to kind of leverage all the work that we're doing and the Amazon backbone and get significant performance improvements. And of course, they get better as you move further away from your destination bucket. So as I mentioned before, it's extremely easy, which really was one of the goals for this service. And so really there's two steps, right? One is on your bucket, you need to go enable S3 transfer acceleration, which is a simple checkbox. And then for your application, when you do the put request, you can simply specify a separate endpoint, and that's it. We also have a tool that's available for you to determine how much performance improvement you will get. So we urge you to go look at that and leverage that to determine if S3 transfer acceleration is a good fit for your use case. All right, so let's focus a bit on some of the other capabilities we've been adding to the platform. And let's start with lifecycle policies. So we talked a little bit about this already, with the goal for lifecycle policies really being making data management easier for customers on S3 and helping customers derive more value from their data on S3. And there are two core actions that you can take with lifecycle policies. One is what's called transition, which is really changing storage class of your data from one storage class to another based on a specific rule, which is really the object age. So for instance, I can set a lifecycle rule that says I need to tier data from standard to glacier when the data becomes a year old. And that we will evaluate on every single one of your objects, regardless of the number of objects in your bucket. And S3 will automatically take your action instead of you as the customer having to list your data and then trying to determine which one of those you want to move to the different storage class. The other action you can take is expiration, right? And so there you can delete objects after a specified amount of time. Again, the same rule, but the action you take is different. You can expire or delete objects based on what rules you set. You have the ability to combine multiple actions. So you, in a given bucket, you can decide to, and you can actually set these at the prefix level. So you can decide to tier objects in a year in one prefix, whereas wait a few months, like 90 days, to tier objects to a different storage class in a different prefix. So you have a lot of control in terms of how you configure lifecycle policies to manage your data in your S3 bucket. For the new storage class that we've announced, as I mentioned earlier, it fully supports lifecycle policies. So you do have the ability to transition data from standard to infrequent access, or data that's in standard infrequent access and archiving it directly to Glacier based on the object age. You can also set expiration policies on data that is in standard infrequent access storage class, and you can also use it with versioning. Right? Versioning is the capability where we allow you to ensure that if you do replace or delete a version of your object, you don't accidentally remove that, and we actually keep that object as a non-current version. So it's identified, you can get to the latest version at any point in time, but since we're not removing or deleting or overwriting the objects, you have previous versions of your object available for you, so you can always recover those. And that, again, works just like it does with S3 standard, with standard infrequent access. And the other thing, of course, is where it makes sense for your use case, you do have the ability to put data directly into standard infrequent access and start saving on storage cost from day one. So here's an example of a lifecycle policy that you can set. And in this example, in the highlighted area, I'm specifying a rule, an action for me to transition data that is in standard. Once it becomes 30 days old, I want to tier that into standard infrequent access, because for my specific use case, I know that my data becomes infrequently accessed after about 30 days. And of course, you can pick a number that's appropriate for your specific use case. I can then set a different action to transition data that is a year old and archive that into Glacier. So both of these rules then work together to provide you the ability to first tier all data that's in standard to standard infrequent access once it becomes a month old, and then a year after that, you can then transition the data into Glacier. And both of these rules work together. So let's talk a bit more about versioning for S3 objects. As I mentioned earlier, this is the ability, versioning gives you the ability to ensure that you never accidentally remove or overwrite your data, and you always have the ability to recover from an accidental operation. And really it achieves that by ensuring that we never really remove a version of the object. So if I had versioning enabled on my bucket and I have an object there which is the current version of my object, if I issue a delete against that object, S3 will not actually remove that object, but rather just make it a non-current version, and then place a delete marker on top, which identifies that there is no current version for this object. If I were to overwrite this object, then the latest version would replace the current version, but we will not remove the previous version. It simply becomes the non-current version. And both of these in tandem ensures that you always have the ability to recover from an accidental operation. And this, of course, is one of the best practices we recommend. We recommend our customers, and a lot of times it's extremely valuable for those accidental overwrites and deletes. It's very easy for you to retrieve retrieve your deleted objects and roll back. And there's basically 3 states in your version when you version in a bucket. By default, buckets are not versioned, so you do have to enable that, and that changes the state to versioning enabled. After that, any operation you do on your bucket, such as a delete, it will not actually remove the non-current version, simply just mark it as non-current. You do have the ability to suspend versioning if you want, in which case we will retain all non-current versions, but any operations you do afterwards, once the bucket is in this state, we will go ahead and actually remove those versions, remove those objects. A lot of our customers actually use versioning along with lifecycle to actually get recycle bin functionality, right? Which really kind of helps you easily recover for those accidental deletes. So with lifecycle policies and versioning together, you can make sure that you have a sliding window of say 30 or 60 days where your data is completely recoverable. Right? You can always roll back at any point in time, and it depends on your business need on how big you want to make that window. But you can use versioning along with lifecycle policies to make sure you don't have infinite number of versions lying around, but at the same time you have a buffer period for your recycle bin. Now, since we talked a bit about versioning, there is a specific use case where when I have versioning enabled for my bucket and I delete the latest version of my object, S3 indicates that there is no current version of this object by placing a delete marker and then making the current version and marking it as non-current. Now, in addition to that, you can actually you can either directly delete a non-current version by using the API, or you can use a lifecycle policy to say a week or 30 days or whatever, however many days you think that makes sense after an object becomes non-current. Go ahead and clean that up for me. Go ahead and remove that for me. So in this situation, you end up with a delete marker which has no non-current versions or no previous versions under it. That is something that you can, by specifying a specific indicator, you can a flag, you can list all of your delete markers, and if you can clean those up yourself. But again, at S3 scale, that is a cumbersome task that customers would have to probably write code for to be able to do. With the expired object delete marker policy, however, you can simply tell S3 to delete any delete markers that do not have any non-current versions under it. Again, taking the onus away from customers so that they can focus on writing their applications as opposed to doing housekeeping on their data in S3. Here's an example of a lifecycle policy where we're indicating that we want to remove non-current versions. You can simply specify a flag that says non-current version expiration, and you can, in this case, I'm saying after 30 days after an object becomes non-current, we want to remove that object. In this case, S3 will make sure that when we do remove when we expire an object, place a delete marker, and remove the non-current version, we actually automatically clean up the delete marker. But if I was not leveraging lifecycle policies to delete my latest version and my non-current versions, in this case, for instance, I don't have a lifecycle rule to expire current objects. I do that using the API directly. S3 the lifecycle platform does not know to remove the delete marker. So I can simply add a flag that says I want to delete expired object delete markers and set that to true. With this, if there is a delete marker with no non-current versions under it, S3 will automatically go ahead and clean that up for you. Speaking of the ability to recover from accidental deletes, one of the best practices I wanted to call out is S3 does have the ability to enable multi-factor authentication, specifically for delete API, which again gives you that additional layer of protection to protect against accidental deletes. When you enable multi-factor authentication, you will be required to not only enter your security credentials, but also a code from an approved authenticated device for the specific delete API, which, if you have this enabled, will make sure that you avoid accidental deletes and permanent deletes for versioned objects. All right, so let's switch gears a bit again and focus a bit on some of the best practices that we've seen, specifically around performance improvement. So one of the things I wanted to talk about was the ability to upload multiple parts of an object. So this is something that S3 allows you to do, where if you have large objects, you can parallelize the upload of those objects using the PUT API, but essentially breaking the object down into multiple parts. This allows you to remove bottlenecks from your network and really kind of leverage the power of multi-threading and parallelism, so that you are uploading multiple parts together. Another added advantage of this, of course, is that you can increase the resiliency of your network errors, specifically for those networks that are error-prone. So, for instance, if you're uploading using a mobile network, it's possible that when you're trying to upload a large object, you see issues with your connectivity, and you would have to restart the entire upload again. But if you're uploading multiple parts, then you just need to restart the upload for a smaller part, right, which makes it much more efficient and adds resiliency to your network. So with multi-part upload, you can add parallelism to your upload that really makes it faster and more flexible for you to do uploads, and allows you to upload a set of parts. And then, of course, once that upload is complete, S3 will automatically present all of those parts as a single object for you. So relevant to this, right, there are cases when, if you're leveraging multi-part upload, it's possible that your application might die or run into an issue where the application dies and does not complete all parts, successfully upload all parts of your object. In those situations, of course, you do have some parts of your object uploaded and you are paying for storage for those. And in these cases, you have the ability to specify a flag in your list API to explicitly call out and list the multiple parts that are not complete. And then you can go ahead and remove those if you think that makes sense. But again, that is a repetitive task that our customers have to do. And based on that feedback, we added this new policy to our lifecycle platform, which is the ability to automatically expire incomplete multi-part uploads based on the age of the upload. So you can simply specify a policy that says if my multi-part upload has not completed in, say, 7 days or 10 days, lifecycle platform can expire the upload and delete all the incomplete multi-parts to take you back to a known good state. So here's an example. It's very simple to set that lifecycle policy. You can simply specify a flag for an action for abort incomplete multi-part upload and specify the age. So 7 days after initiation of my multi-part upload, if the multi-part upload has not completed, go ahead and abort that and delete all the incomplete multi-parts for me. Another optimization you can do is perform range-based gets, right? So in addition to doing multi-part upload, where you upload multiple parts of your object, you actually have the ability to get specific ranges in your object, which is especially useful when getting large objects, because you can use the power of parallelism here as well, and download parts of your object at the same time. Which again compensates for unreliable networks, because when you do have an issue with a specific part, specific range that you're getting, you only need to restart the get for that specific range, and so you kind of add resiliency and benefit from the from parallelism. The same thing is true for list. You can parallelize your list API, and you can do that by specifying so for list API you can get up to 1,000 objects at a time, but you do get an indicator that tells you a marker where to start from for the next set of 1,000 objects. So if, for instance, you wanted to list a bucket with 5 different prefixes, you could at the very least kick off 5 different instances of list focused on specific prefixes. Or if you understand how your bucket is set up and your prefix is set up, you can actually parallelize list requests for a specific prefix as well. Another best practice and a very common usage pattern we see from our customers to optimize lists is actually using secondary indexes. You can use services like DynamoDB to actually set up a secondary index where when you put an object in S3, you keep an indicator for that in your secondary index. And then, of course, you have the ability to add additional metadata as well. Not only does it make lists much faster, but you can also get additional benefits such as sorting and searching based on metadata or other properties of the object. There are a few best practices we talk about as far as SSL and using SSL in an optimal way is concerned. First and foremost, if you use the SDK, we make sure that the SDK always has all of these best practices and more. It is always up to date and leveraging all of these best practices to give you the best possible performance. So if you where you can, we encourage you to leverage the SDK to talk to S3. But there are specific actions you can take, such as if you're using EC2 as your client to talk to S3, you can leverage hardware acceleration on specific instances, and that gives you better performance when it comes to encoding for SSL. You should also try and avoid timeouts, right? You can do connection pooling so that you don't need to do the work to set up the connection every time. You can send keep alives to avoid handshakes, which are expensive and can add up, especially on mobile networks or networks with limited bandwidth. Another best practice is around how you name your bucket. And that really is that we do see usage patterns in our where customers try and leverage prefixes like folders. And if you try and use prefixes to organize your information, while it makes it easier for you to discover your information, especially at higher TPS, and specifically 100 TPS and higher, you start seeing performance implications because a lot of your data is under the covers on similar or the same partition. Now S3 automatically tries to distribute your data in as many partitions as possible, and it automatically, if you start seeing high traffic on a specific partition, we automatically move it around as well, but that does take time. So in the meantime, you will start seeing implications on your throughput and start seeing performance issues. And so here I have an example of a prefix, which is very common, especially when people are putting logging information on S3, that you organize it by year, month, and day. And what that does is all of these objects end up being on similar or the same partitions, right? So all of the objects that have 2013 on here as the first part of the prefix will end up going to the same partition. So on this prefix, if I start hitting extremely high TPS, I might start seeing performance implications for some amount of time. So the recommendation there is to add as much randomness to your key naming as possible. So here is another example where I'm not using a specific year range, but rather I've randomized all of the keys for my objects. And so this ensures that inherently you end up on different partitions in S3, and you never end up having a partition, especially as you scale TPS and your traffic very, very fast, you will never see that implication because you will not have too many of those going to the same set of partitions. There are a couple of techniques that customers use to be able to randomize their keys. One is to hash the entire name of my object. So if you do that, then of course the object name does become randomized, and therefore I don't have the same object name showing up and that data ending up on the same partition. Another approach is to prepend your key name with a short hash, and that again, of course, randomizes the initial part of my key name, automatically sending me to a different set of partitions. Yet another approach is to actually reverse your key name, specifically in the cases when you're using dates. And so if you're doing that, just reversing that may help you introduce randomness. But really it's about randomizing your keys. And with that, let's open up for questions. And let's see what we have there.
Thanks, Omer, for a great presentation, and Drew, Carl, Vo, and Susan for engaging with our audience throughout the presentation. So on your screen, you will see 3 live poll questions. Please provide us with your feedback by clicking the radio button next to your reply for each poll. We have about 10 minutes left, so please feel free to continue submitting questions. We will address some of these as they are submitted, but apologize in advance that we might not be able to get to all of them. So I will hand it off back to Omer and Drew to answer some of the Q&A that we've received.
Thanks, Jenny. We're glad to be here, everybody. So we've got a number coming in, and while you've got us here, experts on the phone, we're happy to stick around and take care of them. So we'll do the best we can. Hey, Omer, I've seen a couple of conversations about lifecycle policies. One of them particularly, can you apply a lifecycle policy to move stuff into SIA at a bucket level and not just a file level?
Mm-hmm.
Does that make sense?
Yeah, and the answer is you can. So with lifecycle policies, you have a lot of control in terms of where you apply what actions, right? As I mentioned earlier, you can specify these at a prefix level. In fact, you can specify different actions to different prefixes, but you can always decide not to specify a prefix, right? And so the policy can then apply to every prefix within your bucket. That essentially makes it a bucket level policy. As far as the action is concerned, you do have the ability to tier data from standard to standard-infrequent access, and that simply is one of the actions that you place in under transition.
Okay, cool. And then, hey, Vo, I think there's some questions here about S3 transfer acceleration, particularly around performance. So if you could just kind of talk us through why, in some cases, it may be 1 to 15% better. In other cases, it may show dramatically better. And also, how can I test it when I'm thinking about whether this will affect my own particular situation?
Okay. So S3 transfer accelerate gives benefit to over regular S3 uploads if the distance between where you're uploading from to your destination S3 bucket is far away. I think an example given is if you were on the East Coast, let's say Maryland, and you're uploading to the Virginia region, you're not likely to see a large benefit. If you go further away, for example, you're trying to upload from Los Angeles to the Virginia region, you'll see a moderate benefit. And then if you're even going further away, for example, if you're going from Japan and you're trying to upload to your Virginia bucket, you're going to see you should see an extreme benefit. So your benefit is going to be based off of how far away you are from the bucket.
That's really helpful.
Yeah, and then, in terms of speed comparison, there is a speed comparison tool that is on the S3 page that you can look at when you click on your bucket. That should give you a good indication the benefits you will see, so you can run comparisons uploading to different buckets.
Excellent. So I can just run a test from wherever my client is and see what my results might be.
That is correct.
Okay. Omer, can you talk about best practices on bucket naming or using folders in their names? I think you touched on it, but it seems to be a really important issue.
Absolutely. So the key thing to remember there is you want to make your bucket, your prefix names as random as soon as possible, right? So a little bit about buckets and prefixes. So once you name your bucket, S3 essentially is a flat structure, right? So when I put an object in S3, I can add more prefixes to it, which kind of show up as folders in the UI. And I can say, you know, for bucket B1, I want to put all of my JPEGs under a folder or a prefix called images, right? So it'll be my bucket name / images / all of my, all of my objects. The issue with that then is, if you think about it, the prefix starts right after the bucket name. So the bucket name followed by all of my billion images that I put in S3 are going to start with IMAGES, right? Images. And so the issue with that then is, as you start pumping high TPS to these set of images, because the prefix initially is similar and is the same, S3 tries to put them in the same set of in the same set of partitions where possible. Now the impact of that, of course, is if I start hitting 300 TPS and start getting lots of these images for my specific workload, it's going to be the same set of hardware, the same set of partitions under the covers that are going to start pulling this information and sending it back to you. Which then does mean, because it's the same partition, there are physical limits, and you start seeing performance implications there. Now, on the flip side, if I had said, you know what, I'm going to hash or add a four-character hash in front of the folder name images, and so my bucket name then looks like my bucket name / hash which is obviously random _ images and so forth. In that case, the data under the covers is going to be on random partitions, because it's going to be the first few characters that we look at when we're putting the data in a specific partition. So when you do a put request and we look at, okay, where does this end up? We first look at the first random 4 digits, and it organically ends up in a different partition. So now when I drive the 300 or 400 TPS to my bucket, it's actually going to be talking to a different set of hardware, which inherently makes sure that you do not see any performance implications there. So really it's about, when you sit down and think about naming your buckets and the prefixes within your buckets specifically, it's always a good idea, especially for those high TPS and high volume prefixes and buckets, to randomize the initial part of your key name where possible.
How do you, so I understand the randomization value, but how do then you handle customer challenges around navigation when the logical structure gets sorted at a random level? Mm-hmm. Your files you're naming, yeah, yes. Okay. So
that's where one of the common patterns we see for our customers is using a secondary index. So if I were using a DynamoDB index where I said, you know what, I wanted everything to be under the folder images / the name of the file. Every time I put an object in S3, I can simply add a row to my table in DynamoDB to say, for an object that I want to put under bucket name images, image 1, the actual name in S3 is bucket name random hash and so forth, right? So that therefore you keep that mapping around, and so every time you want to do a lookup, you can simply go to DynamoDB to know, okay, for my image 1, which I know is under images, what is the actual key name for it, right? So once you maintain that mapping between key name and the logical structure you want to have, then you can simply look that up and go back and forth from there.
Thank you. All right, and I think the time is just about up, and unfortunately we're not going to be able to get to everyone. So Jenny, do we have time for one more, or do we need to pull the plug right away?
We are actually out of time. So I'd like to just say thank you, everyone. Thank you to Omer, Drew, Carl, Vo, and Susan for answering the audience's questions. If you have any comments on our previous or upcoming webinars or suggestions on topics, please feel free to email us at aws-webcast@amazon.com. Your feedback will help us improve our webinar programming. Thank you to the audience for taking your time to join us today. Enjoy the rest of your day.